Hey guys, today we're going to talk about some properties of logarithms, and we're really only going to go over some highlights from this set of notes here. When you see two logarithms with the same base added together, you can condense that to a single logarithm with the same base, and the argument is the product of these two, x times y. If you see two logarithms with the same base and they are subtracted, you can divide the arguments. So it would be log base a of x divided by y. And if you see a logarithm with a coefficient, that coefficient can come back here as an exponent. So that is the same as log base a of x to the y power. So we'll answer a few things along the way here until we get toward the bottom of the second page, then we'll do a lot there. So log 5, so that's a base 10, and log 7, another base 10, added together is the same as log base 10, which is common log, 5 times 7, which is 35. Log base 5 of 3 plus log base 5 of 7 is log base 5 of 3 times 7, 21. Now subtraction, log 33 minus log 3 is the same as log 33 divided by 3, log 11. Log base 9 of 24 minus log base 9 of 4 is log base 9 of 24 divided by 4, which is 6. Three times log 6 is the same as log 6 to the third power, which could be simplified as well. 6 times 6 times 6 could also go there. And then 3 times log base 7 to the fourth is the same as log base 7 of 4 to the third power. So we can always just move that coefficient to the back as an exponent on the argument. So condense the following. So we've got log base 8 of 4 plus log base 8 of 5. That is log base 8, 4 times 5 is 20. Log base 3 of 21 minus log base 3 of 3 is log base 3, 21 divided by 3, 7. 2 times log base 4 of 9, so I can move that back there as an exponent, so that's log base 4 of 9 to the second power, which I could also simplify to 81. And then I've got 3 here, log base 9 of 5 plus log base 9 of 6. So that's log base 9, 5 times 6 is 30. And then minus 2 means divided by 2, so that can be simplified even further to log base 9 of 15. Okay, so that is condensing. Now we're going to reverse that and expand. So when you condense, you take multiple logarithms down to 1. When you expand, you take one logarithm and expand it to multiple logarithms. So we've got a 3 times y in the argument, so that means this is the same as log base 4 of 3 plus log base 4 of y. Okay, here we are multiplying again, so we can split it up into 2 logarithms with addition. Log base 6 of x cubed plus log base 6 of y to the 5th. But we can also take that exponent and move it to the front of each logarithm. So our fully expanded form is 3 times log base 6 of x plus 5 times log base 6 of y. Here I've got three different variables, so I'm going to have three different logarithms. First, I've got y to the third power, so that would be 3 times log base 7 of y. Then times z means plus log base 7 of z. And divided by x to the fourth means minus 4 times log base 7 of x. And then log, common log, so base 10, fourth root of 8, that's the same as log 8 to the 1/4 power, which can be rewritten as 1/4 times log 8. And last, evaluate log base 4 of 7 over 12 using this information. I have a value for log base 4 of 7. I don't have a value for 12, but I have a value for 3 and 4, so I can rewrite this as log base 4 of 7 over 3 times 4. Then I can expand that to log base 4 of 7. Since it's divided, that will be minus, and I've got two logs to add here. So in parentheses, log base 4 of 3 plus log base 4 of 4. And now I can substitute. Log base 4 of 7 is 1.40 minus log base 4 of 3 is 0.79, and log base 4 of 4 is 1. So that's 1.40 minus 1.79. So I'm subtracting a larger number from a smaller number, so I know it's going to be negative. 1 minus 1 is 0. 40 minus 79 is negative 39, so I've got negative 0.39.